Okay, so now, as I said, the first part is the embedded system part. The first part is the embedded system part. And as I said, with embedded system, what you have to do is that you need to be able to select a board. So we are going to see how to set up the hardware very fast. Within like 5 minutes, we'll be done with this one. So how do you set up this hardware? And then you guys know what this hardware is, right? I mentioned it. I mentioned. I said it's called what? Do you know what? No, no, right? Okay. Okay, so this board actually it's actually for what is known as tiny machine learning. Have you guys heard of it before? Tiny machine learning. Have you guys heard about it before? No. You know, we have kind of conventional, as I said, machine learning require a lot of memory and speed, right? So they are normally run on high-end CPUs and stuff like that, right? But once you begin to run machine learning on high-end CPUs, it means that you must pick some sensor values or sensor data and send it to a central server for it to do the machine learning for you and then send you back the results, right? And then this creates a lot of issues. You guys know that, right? Probably, let's say, let's say you have a pacemaker, right, in your chest, right? You guys know what a pacemaker is. If you have a pacemaker in your chest and then you are supposed to detect whether your chest or your heart rate is beating normally or abnormally, right? Imagine that we send the data, this data is sent to some central server, and then that central server will now determine if your heart rate is normal or abnormal, then it sends you back some feedback. You see that there will be an issue, right? What do you think are the issues? What do you think are the issues with this kind of system? I have a pacemaker in my chest, but the pacemaker is just a sensor, right? It just picks up my heart rate or the heartbeat or something like that. And then it can't do anything else. It just picks up. And then I have to send, this data is sent to a central server, probably somewhere else. And then it does some kind of machine learning on it. And then it brings me back the results and tells me that probably on my phone that my heartbeat is normal or is abnormal. What do you think is an issue with this kind of system? Hey, this simple question is fine. Then you guys are there. As I'm the zeros and change, eh? Zero, 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 zero. I mean, if you don't see an issue with this, like if you don't see issue with this, then zeros in change. Then if okay, your sure bet is just to come to class and get 25% and just answer questions, and probably you just get 40% and go away. I mean, that's a pass mark, right? What do you think? Yeah. Why? Okay, that's fine. So internet connectivity. So there's an issue. That is if you cannot receive back the information, right? So that's one. Another one. So we have an internet issue, right? Then what? Huh? Hurry up, hurry up, hurry up. What? Huh? Store. Uh-huh. It does not work. Massa. Okay, okay, okay. Speak tree, and then let's go. Speak tree, speak tree, speak tree, speak tree. Okay, okay. I mean that's fine. I mean, anything else? Oh no, 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 no. Twitter, yeah.
The time it takes for it to bring it back. So processing speed.
Yeah, no processing speed. Latency. So you send in, it means that you send information to some central server. That takes some time, right? That central server send you back information another time. So you have latency issue. Then what? If itself, there's a very one of the most important. That's why I even use a personal thing like the heart. There's a very important issue there that you guys have not even mentioned. What? Just one thing. If you in case you're able to mention it, that person automatically the 5 marks is just for you. You don't have to answer any question again. Very very basic issue. Security. So that's why I use the hat. So imagine that imagine that somebody you have a you have a middleman, right? You are here. Somebody your heart rate is being sent over the internet or over whatever communication to a central server. There's a middleman that captures that information, and then a middleman knows how your heart is beating. So you know what they can do to you. Even okay, probably that person captures the information. Your heart rate is normal, right? That person immediately sends you information that you're about to die, like your heart rate is beating. Just imagine the panic. Right? Even that will cause your heart rate to also actually beat faster, right? So that's the main issue is security. So let me take your name. What's your name? Huh? Your name is what? Index number. Okay, I have it. You know that, and I have an idiotic memory, right? I remember everything. All right, so these are the components that you'll be using, right? So this one is known as the tiny machine learning. So as I said, so all we are saying is that because of this kind of issues, right? The internet issue, latency issue, and then the security issue, right? You would like to process data as close to the edge as possible, right? So if you have a pacemaker, the pacemaker is supposed to be able to process the data and give you immediate information other than sending it to a central server. But you know that this kind of algorithms, running those kind of algorithms will need a lot of RAM and stuff like that. So you need another version of machine learning, right? Simplified machine learning that will be able to run on very low cost devices, right? That's what we term as tiny machine learning. It's machine learning, but not conventional machine learning that requires a central server and stuff like that. It requires that the information or the machine learning must run on the hardware, on the edge device, probably your phone, or the MCU and stuff like that. That's tiny machine learning. And then this board is capable of that. It's capable of running machine learning on its own without sending it anywhere. Right? Right. So now the board has the tiny machine learning kit. It's a whole kit. It has the board, the main microcontroller is known as the Arduino Nano 33 BLE Sense. Right? There are so many Arduino Nanos, about 7 versions. Each of them does what it does. And then this one is known as the Nano 33 BLE Sense. The BLE means that it has an integrated Bluetooth. The Sense means what? It's what? Higher up, higher, higher up. The Sense means what? The sense just means that it has sensors on it, integrated sensors. You know that if you buy your normal Arduino Uno, there's not even one sensor on it, right? You must buy all the sensors. This one has a lot of sensors. Probably it has light sensor and some other sensors, light and then others. About 4 or 5 sensors integrated on it, right? And then we have a camera here. I believe you guys know the OV camera models. You guys might have used them before, right? And it has a shield for easy connection, right? So this is what we are going to learn how to program. This is just basic. This is just basic. This is just basic. So if you buy this kit, right, it comes with the camera, it comes with the board, and then it comes with the shield, right? But sometimes you can buy them individually too. Just buy this board, right, and buy the camera, and then you can use a breadboard and I believe so many of you have used a breadboard before, right? And I believe somebody has never even touched a wire before here. Who? Somebody here has done computer engineering for 3 years and has never even touched a wire before. Okay, but so what I mean is that you can buy the individual components and then you can wire them up yourself using a breadboard. And then the wiring diagrams are here, stuff like that. And this is known as the pinout of the Arduino board, right? Very, very important. So as an engineer, you should know what each component or each component here means. Right? You should know what D13 means plus 3V3 means what? Anybody? So anybody who answers that one will get 5 marks free. Plus 3V3 means what? Have you guys ever studied look at the second component, the second pin. After D13, have you seen D13? Master, where are you looking? Master, where are you looking? This one, the second one. After D13. I hope you guys know how to read schematic of a component. No. Yes. No. As an engineer. Oh, hurry up. So plus 3V3 means what? Huh? Uh-huh. Master, I can't hear you. Guess what? 3.3 volts, so another 5 marks there. So simple. So we're going to learn how to read the components of an MCU, and you'll be fine. Right, they're still on the pinout, and then if you connect it to your breadboard, this is how it will look like in some bizarre way. But once you have the shield and stuff like that, you see how neat it is, right? Okay, okay, so this is how to actually set up your hardware. I mean, I shouldn't even be telling you all this. It's an insult to your intellect, right? Basic script.